In this video, we will compare three common methods for factoring a trinomial in the form ax squared plus bx plus c with a not equal to 1 and no common factor other than 1. We will look at the methods of trial and error, factor by grouping, as well as bottoms up. Let's begin by using the method of trial and error to factor 3x squared plus 11x minus 20. Notice how there is no common factor other than 1, and therefore if the trinomial does factor, it will factor into two binomial factors. The first step in the trial and error method is to place the factors of ax squared in the first positions of the two binomial factors. Ax squared is equal to 3x squared, and 3x squared is equal to 3x times x. Let's place 3x in the first binomial factor and x in the second binomial factor. The second step is to place the factors of c, which in this case is negative 20, in the second positions, such that the sum of the inner and outer product give us a sum of the middle term, which in this case is positive 11x. Let's list all the factors of c, where again c is equal to negative 20. So c is equal to negative 5 times positive 4, negative 4 times positive 5, negative 2 times positive 10, negative 10 times positive 2, negative 1 times positive 20, and negative 20 times positive 1. Notice how we do have quite a few factors to try, but typically if we ignore the signs, we normally use the factors that are closer together, and therefore let's focus on the factors of negative 5 and positive 4, as well as negative 4 and positive 5. Another consideration is that when placing the factors of c into the two binomials, we will never have a common factor in the binomials, because if we did, there would have been a common factor in the original trinomial. If we want to use the factors of negative 5 and positive 4, let's place a minus 5 in the first binomial factor and a plus 4 in the second binomial factor. And now we check the sum of the inner and outer products. Notice how the inner product is negative 5x. We have negative 5x plus the outer product is 3x times 4, which gives us 12x. So we have negative 5x plus 12x, which is equal to positive 7x, not 11x, and therefore this is not the correct factorization. And again, because this is the trial and error method, we now just try something else. Let's try changing the position of the two factors. Let's place the plus 4 in the first binomial factor and the minus 5 in the second binomial factor. And now we check the sum of the inner and outer products again. The inner product is now 4x, so we have 4x plus the outer product is negative 15x. 4x plus negative 15x is negative 11x, and we want positive 11x. So in this case, when we have the right term but the wrong sign, it's an easy fix. We simply change the sign of the two factors. So let's change the plus 4 to minus 4, and the minus 5 to plus 5. And let's go ahead and check this again. Now the inner product is negative 4x, plus the outer product is positive 15x, which notice how it does give us a sum of 11x, which is the middle term, and therefore we now know this is factored correctly. The correct factorization is the quantity 3x minus 4 times the quantity x plus 5. And remember, the order of the binomial factors does not matter because of the commutative property of multiplication. Now to compare, we will factor the same trinomial using the method of factor by grouping. The first step in the method of factor by grouping is to find the factors of a times c that add to b, where for our trinomial a is equal to 3, b is equal to 11, and c is equal to negative 20. So ac is equal to 3 times negative 20, which is equal to negative 60. We need to find the factors of negative 60 that add to b, and b is equal to 11. So let's list the factors of negative 60 until we find the two that sum to 11. We have negative 6 times 10, but negative 6 plus 10 is positive 4, not 11. And we have negative 10 times 6, but negative 10 plus 6 is negative 4, not 11. Let's try negative 15 times 4, which does give us negative 60, but negative 15 plus 4 is equal to negative 11, not positive 11, which again means we need to use the factors with the opposite signs. So let's try negative 4 times positive 15, which is negative 60, and negative 4 plus 15 is positive 11, and therefore the two factors we need are negative 4 and positive 15. And now we use these two factors to rewrite the middle term 11x as negative 4x plus 15x. So we take the original trinomial and write it as 3x squared minus 4x plus 15x minus 20. Again, we use the two factors of AC that added to b to rewrite the middle term as a sum or difference. And now that we have four terms, we can factor using the method of factor by grouping. So now we divide the expression in half, where we have two terms on the left and two terms on the right. And now we factor out the greatest common factor from the first two terms and then from the second two terms. The greatest common factor of 3x squared minus 4x is x, and therefore we factor an x out of the first two terms. If we factor x out of 3x squared minus 4x, we are left with a factor of 3x minus 4. And now we factor the greatest common factor out of 15x minus 20. The greatest common factor is 5. Because we factor out a positive 5, we write plus 5. And then if we factor out 5 from 15x minus 20, we're left with 3x minus 4. Remember, when using the method of factor by grouping, these products should always have a common polynomial factor, which in this case we can see is 3x minus 4. So the last step is to factor out the common binomial factor of 3x minus 4 from these two products. So if we factor out 3x minus 4 from the two products, we can see we're left with a factor of x plus 5. This is the correct factorization of the original trinomial using the method of factor by grouping. And again, notice how we do get the same factorization from factor by grouping as we did from trial and error. And now for the last method, let's factor the same trinomial using the method of bottoms up. The first step in the bottoms up method is to multiply a and c and then rewrite the trinomial in the form x squared plus bx plus ac. So again, a is equal to 3, b is equal to 11, and c is equal to negative 20. A times c, again, is equal to 3 times negative 20, which is equal to negative 60. So we rewrite the original trinomial as x squared plus 11x minus 60. And now we factor this like we normally do with a leading coefficient of 1. If this does factor, it factors into two binomial factors, because the first term is now x squared, and x squared equals x times x. We have a factor of x here and a factor of x here. And now because the leading coefficient is 1, we need to find the factors of negative 60 that add to positive 11. Let's list the factors of negative 60 here on the right. Let's focus on the factors of negative 15 and positive 4, as well as the factors of negative 4 and positive 15. Again, we're looking for the factors of negative 60 that add to positive 11. Well, negative 15 plus 4 is negative 11, not positive 11, but negative 4 plus 15 is positive 11. The factors we need to factor this trinomial are negative 4 and positive 15, which means one binomial factor is x minus 4, and the other is x plus 15. Now this is the correct factorization of this trinomial, not the original trinomial. The next step in the bottoms-up method is to now divide the constants in each binomial by the original value of a. In our case, a is equal to 3, so now we divide the negative 4 by 3 and the positive 15 by 3. And now we simplify the fractions. If the simplified fraction does not have a denominator of 1, we move the denominator to the coefficient of the variable. So notice here we have 4/3, which does not simplify, which means we move the denominator of 3 to the coefficient of x, which gives us a factor of 3x minus 4. Looking at the second binomial, notice 15 divided by 3 simplifies perfectly to 5, and therefore the second factor will be just x plus 5. This is the correct factorization of the original trinomial using the method of bottoms up. And once again, this is the same factorization we found using the method of factor by grouping as well as trial and error. I do want to mention, in my opinion, of these three methods, it is important to get competent using the method of trial and error, because over time it does tend to be the quickest way to factor more complicated trinomials. I hope you found this helpful.